We're going over an indirect proof, right? So this is from the worksheet. I'll write this down. This is from worksheet 5.4. And let's do number 6. We'll do the geometry one first, then we'll look at the algebra one. To tell you the truth, I think sometimes the geometry one might be a little bit easier, but we'll see. Yeah, I think so. So let's do a triangle right here. Here's a triangle. Let's label it EDF, DEF. Alright, and they tell you the given. Now remember, what did we say was some of the best times to do an indirect proof is when you're trying to prove that something is not equal, okay? When you're trying to prove that something is equal, usually you can do it directly. But if you're trying to prove something that is not equal, then that's a really good time to use an indirect proof. So it tells you that angle D is not equal to angle F, all right? And you're trying to prove that line segment DE is not equal to line segment EF. Actually, what's the difference between putting the line segment over top of it and not? What does it mean? It's the measure of, right? It's the measure or the length of the line segment, okay? Does that make sense? Okay, so it's, anyway. So let's do this. What do we assume? We assume the opposite, right? So we're going to do some writing here. So we assume, what are we trying to prove? We're trying to prove that DE is not equal to EF. So we assume the opposite. So let's assume that DE is equal to EF, right? So if we can come to a contradiction, right, then what we assumed in the first place will be false. And then that means what we're trying to prove is actually true. Let's take a look at this picture, though. It says angle D is not equal to F. So let's put one little arc right here, and we'll put two arcs right here. That means that D and F are not equal to each other. Would you agree with that? Okay, because one has one arc, one has two. So it's given that they're not equal to each other. But what are we assuming, though? We're assuming that DE is equal to EF. So let's put a little tick mark here. Tick mark here, tick mark there. Agree? So we assume that that's true. Does that bother you? Why? Because if those two sides are equal to each other, then it's an isosceles triangle, which means what? That the opposite angles are going to be equal to each other. So if we say that DE and EF are equal to each other, all of a sudden, right away, I see that that can't be true, right? So what do we say? Assume then, if that was true, if we're assuming that DE and EF are equal to each other, what must be true if that stuff was true? That's right. So angle D must equal what? Angle F. Because opposite angles, or sorry, angles opposite, how do we say that? Yeah, isosceles triangle theorem, right. I used to teach out of another book that used to have to say the whole thing. So we would say that the angles opposite equal sides are equal. That would be the reason. But this book puts a theorem name to it, so we would just say isosceles. We'll do it like this, by the isosceles triangle theorem. Okay? Short it like that. But what does this do, though? Can angle D equal angle F? No, it can't, because what was given? It was given that they don't. So they can't be equal to each other and not be equal to each other at the same time, can they? No, so what do we just do? But this contradicts, doesn't it? It contradicts, what does it contradict? The given, right. So we're going to say that. It contradicts the given that says angle D does not equal angle F. Does that make sense? So it contradicts the given that says angle D is not equal to angle F. That's our contradiction. Yeah, I'll show you this. In college, wait a minute. Yeah, this is not in college, we learned the contradiction. There's actually a symbol in math for the word contradiction. and it looks like a tic-tac-toe symbol. So sometimes I'll do this. So angle D equals angle F. That's our contradiction, isn't it? So if you wanted to, you can put little tic-tac-toe thing. That just shows you, like, when you're looking. What did I say? Did I say number sign? What did I say? I guess, but tic-tac-toe. Isn't that tic-tac-toe?
Or it could be the pound button on a telephone, you know?
All right, come on, give me a break. All right, it still could be a tic-tac-toe, couldn't it? All right, I don't have to go through every single possibility this thing could be. It looks like tic-tac-toe. It's all right. It's real tiny people playing tic-tac-toe. You can have that. All right. Anyway, so it's just kind of nice when if you had a longer proof and you're just scanning through and you want to find out where your contradiction is, instead of writing every word or reading every word, you can just look to see the contradiction symbol and you can find out where your contradiction is, okay? You don't have to do that. It's just something that I learned a long time ago, and if you want to put that in there, feel free to do that, okay? It says, but this contradicts the given that angle D is not equal to angle F. So, what we assumed was what? Was false. That's right. What we assumed, and what did we assume? We assumed that DE was equal to EF must be what? False. Yeah, you could word it however you want. I'm just wording it like this. Okay? It doesn't have to be word for word exactly like I've done here. But so what we assumed about DE equaling EF must be false. Therefore, did you know there's a symbol for therefore?
Oh, no.
Looks like a triangle, but they're just dots at the vertices. You don't.
That takes longer.
Okay.
Just write out there.
No, it doesn't. Therefore, what? If DE equals EF is a false statement, therefore, what can we say? DE must what? If this is false, listen, if this is false, what can we say now? That's right. Then it's not equal to EF. And there you go.
So you always...
And then that's your proof right there. Yep.
So
Contradiction. We just had 10 minutes talking about that. Okay.
Do you have to prove the given wrong? Like that's
Yes.
the way that you can prove
Yep.
it wrong? Okay.
You want that's your contradiction.
That's what I was confused about.
That's what your contradiction is, okay? But your contradiction is that if these two sides are equal, these two angles must be equal. But what does that contradict? It contradicts the given, right? I don't think every single proof is going to contradict the given, but it will contradict some statement, okay? It'll contradict something. In this case, it contradicts the given, that D cannot equal F, right? Follow me?
What else could it contradict?
Nothing. That's it.
No, I mean, you said it's going
well, you could have a long drawn-out proof with a bunch of other stuff. I'm not going to sit here and try to make something up. I don't know. But there could be other information, maybe, that was drawn on the picture. I'm not really sure. I'm just saying that it's not always going to contradict the given. There could be other stuff that you could figure out about it, and it contradicts that. I'm just not sure, okay? I'm just saying that, in this case, yeah, it does contradict the given, that D and F cannot equal each other. Does that make sense? So hopefully write that down. Take a look at it. And it's actually kind of interesting. We'll do another one.
Can you do 5?
Yeah, let's try 5 right now. 5 is kind of an algebraic one. So we're given... x squared plus 8 is less than or equal to 12. We're trying to prove that x has to be less than or equal to 2. Okay, here it is. How do we start it off? Assume. No charts. Assume what? We're trying to prove this, aren't we? So we assume the opposite of what we're trying to prove. So assume x is what? Greater than 2. Right? We don't just say it's not less than or equal to. You only have 3 choices, don't you? They call that a trichotomy. You ever hear that? A trichotomy. Tri meaning what? 3. So there's 3 choices. Either a number is less than another number, or a number is greater than another number, or a number is equal to another. Are there any other possibilities? No, there's not if you compare 2 numbers. So you've already taken care of less than or equal to, so what's our only choice? Greater than. Does that make sense? That's a trichotomy. So let's assume that x is greater than 2. Tell you what. I'm going to cheat a little bit, see how they do it. I've got an idea of how I want to do this. but I just want to see how they approach this. Because you could probably just stick some numbers in, and that's what I'm thinking they might do, but I'm not sure. Do they? No, they do it a little bit differently. Yeah. I'm not going to do it like they do it. I'm going to do it like this. Watch. Assume x is greater than 2. Then, let's pick a number that's greater than 2.
4.
Okay, 4. Whatever. You want to pick 4?
Yeah.
All right, put 4 in here. So then, 4 squared plus 8 must be less than or equal to 12, correct? Because that's given. It's given that that's true, right? So if I take a number and I stick it in here, this must be true. Unless I pick a number I can't pick, right? Because I just picked 4. I just picked 4 out of the blue. It's not just any random number out of the blue. What is it? It's a number that's greater than 2. All right, so I picked a number that's greater than 2. All right, I could pick any number that's greater than 2. We just picked 4. Andrew. Yeah, take a pass. So I picked a number that's greater than 2, stuck it in here, and let's see if this is true. 4 squared is 16 plus 8 is what? 24. Is 24 less than or equal to 12? No, it's not. So what did we just find right here? Contradiction. We found a contradiction, okay? So what was our contradiction? It contradicts the fact that x squared plus 8 is less than or equal to 12, doesn't it? All right, so what we assumed about x being greater than 2 must be false. Therefore, x must be less than or equal to 2. I'll show you what they do, maybe. I don't know if yeah, I like this better too. I don't know if this is officially the best way to do it, but they say this. They say assume, okay, of course that was right, that part was right. And they said if, I'll just write what they write, if x is greater than 2, because we assume that, correct? Then they just looked at x squared. Watch this. Then x squared must be greater than what? Look, if x is greater than 2, x squared has got to be greater than what? Let's say x was equal to 2. Then x squared would be what? 4. But if x is greater than 2, x squared is greater than 4. I don't know if I would have ever thought of that. Okay? Yeah, that's why I went this route. Okay? Because let's not do it this way. This is the way they write it in the answer key, but I think we're okay with this. I left some stuff out. I left some words out. You can fill in the words. I'm just not going to write every single word for every one of these proofs. Okay? Yeah, I think what we put is okay. Yeah, it's not exactly, because you got to say what we assumed about, this is false, therefore, all that kind of stuff. Let's try another geometry one. In fact, I don't think that I give you I don't think I give you an algebra one on the test like that. Okay, here we go. Let's take a look at this. Let's do one that's not triangles. All right? Nah, we're not going to do any more abs because I'm not going to have that on a test or a quiz. I'm sticking with the geometry ones. You recognize this situation? Is it parallel lines?
No. You should put
So look at this. How do you know I copy and paste? You didn't see my fingers hit the keys.
So I saw you copy and then you hit paste.
You didn't see it.
Yeah.
You could have turned on super speed and drawn another one.
This is from this is another worksheet. Feel better? Okay. Good. You writing this down? Just write it down somewhere. Write it wherever you want to write it. I don't care. It's just not on the desk. All right, here we go. We are ready. Let's take a look at this. It's given that angle 2 and 3 are not equal to 180. Okay, so 2 and 3 are not supplementary. Right? We want to prove that A is not what? Parallel to B. Right? So, what do we assume? That's right. So we assume that A is parallel to B. All right? So, if A was parallel to B, what could you say about some of these angles? Alex? That's right. So, if we assume that these are parallel lines, right, that's our assumption, then angle 2 plus angle 3 must equal 180 degrees. Would you agree with that? Why? Because of, what was the rule? Remember the words?
Because of consecutive interior
Wow, it took you a while. Yes, consecutive interior angles. We'll just call it the theorem. Not 2 and 3. 2 and 3 is not alternate. They're on the same side of the transversal.
But I thought if they were consecutive, 2 had to be where 3 wasn't.
Right here?
No.
Here?
No.
I don't know what you're saying. Here?
Right there.
No, it's corresponding. That's corresponding. Okay? This is consecutive interior. These are interior. Look. Whoever's tapping needs to stop. How do you not hear that? I think you're doing it on purpose. Go to fifth period, okay? That they do that in fifth period. We don't do that in here. So look. So this angle right here is not even an interior angle. So you couldn't say that this one and this one are consecutive interior. They have to be interior, correct? So you have to be in between A and B. So 2 and 3 are the only ones that are in interior. So anyway, because of consecutive interior angle theorem, which says what? If they are supplementary, then what? Then the lines are parallel, okay? Or the other way around. If the lines are parallel, then the consecutive interior angles are supplementary. All right, so anyway, so we assume that. Then this must be true because of the reason, right? Write down what the reason is. That's always a good thing to do. But what did we just do right here? We just did what? We just contradicted this, didn't we? We contradicted, so a little contradiction sign. So we, what do we say? But this contradicts, right? So you're right. That's a weird B, but that's okay. You know? This contradicts. Yeah. This contradicts the given that says what? That angle 2 plus angle 3 is not equal to 180. Do you see that? It can't be both, can it? Look, I said right here that is equal, but the given says that it's not equal. Therefore, our contradiction, right? So this contradicts the given. So, what we assumed is what? Right, what we assumed about what? About A being parallel to B is false. Therefore, right? Therefore, A is not parallel to B. Were you not here? Come on, we've talked about that like 3 times. Pay attention. All right, therefore, A is, it's not that big of a deal. It's pretty easy now after you get the hang of it, doesn't it? Sure it is.
I like that.
I didn't ask what you liked. I just asked you about this. This is not as bad as what you thought it was. Okay. You just kind of follow the same pattern, right? You find a contradiction. Now look, these were pretty easy, I got to tell you. There are some problems, some proofs that are quite a bit more difficult. We're not going to really get real heavy into it, okay? This is about as difficult as it's going to get on the test or quiz, okay? Yeah. All right, so, but I just want you to understand that there are proofs out there that have to go through several steps, and you got to do a whole bunch of stuff to be able to see the contradiction and everything else. These, all I'm doing is just trying to you know how a rock skims off the water, right? That's all we're doing right now. We're not going deep, all right? Skims or skips, the same thing, right? Skimming, which means you're just hitting the surface, right? Okay? Not a full chapter test, no. All right, so that's proofs, okay? You wanted it recorded? There it is. You better watch it. You better watch it now.